Alright, so I'm making a video continuing a series I was kind of doing before. This is, I think it's Kenneth Crane is the, let's see, this is the actual book. I've done a couple of these problems before. Kenneth Crane, yeah. Just going through his different problems they have. I think I did some in chapter 1 earlier, and I'm doing some in chapter 2 now. I have already taken this class, so I am not completely inept like I feel I am with courses that I'm currently taking. So hopefully I can help people out with it. So this says the distance from New York to Los Angeles is about 5,000 kilometers and takes about 50 hours in a car driving at 100 kilometers per hour. How much shorter than the 5,000 kilometers is the distance according to the car traveled? And how much less time than the 50 hours do they aids during the trip? So part A is a length contraction question. That's pretty clear to tell. They're asking about how much shorter the distance is. So our equation for length contraction is L equals L naught over gamma, or L naught times the square root of 1 minus V squared over C squared. So this is our relativistic length contraction. I think I've actually talked about this conceptually in my other videos. So that's our equation. I'm going to go ahead and convert a few things. Our L naught is our rest length. So you could think of that as from like an outsider's perspective, from a stationary point of view. How long is it? How long is the distance that is? So the distance is 5,000 meters or kilometers. That's what it says in the question. So we're just going to convert that by multiplying it by 10 to the third meters. So that's just coming from this. This is the rest length. The other thing we need to convert is the speed, V. And the problem, it says 100 kilometers per hour. Now because our equation is working with C is the speed of light. C has units of meters per second. If you square it, it's going to be meters squared per second squared. But the reason I'm bringing that up is because we need to convert this into meters per second. Otherwise, our units don't make sense. So, okay. 1 kilometer is 1,000 meters. And 1 hour is 3,600 seconds. So let's see, your kilometers drop, your hours dropped, and you're left with meters per second. So all is good. And if you plug this in, you get about 27.78 meters per second for your velocity. Okay, so the next thing we need to do is talk about what the question's actually asking, which is, I think it's a little bigger too. How much shorter is the distance? In other words, they're asking for delta L. If we think about what they mean by how much shorter is the distance, you're comparing the contracted length with the actual length. So, in other words, L naught minus L. This is the, I guess you could think of it as actual length. I know it's kind of depending on your perspective. That's the whole idea of it. But that's probably a really bad thing to say now that I'm saying it out loud. But the rest length compared to the contracted length. So that's the difference between them. And the reason why I did the proper length is because the proper length will always be longer than the contracted length. L is going to be smaller because it's shrinking as the speeds increase. So hopefully that makes sense. So this is really what we're looking for, delta L. L naught. But we know what L is. L is right up here. Kind of wrote everything, but L is right there. So I'm just replacing that with what we know L to be. Okay. Now I'm going to factor out a L naught. Now you can plug this into your calculator now, but what you will probably get, because the speed is so slow in comparison to the speed of light, you're probably just going to get the exact same answer. And it makes sense because if you plug this in your calculator, this number is so much smaller than this number that it's almost like that number, the whole fraction is 0. Which means it's 1 minus the square root of 1, which we know to be just 0. So, there is no difference in length, is what that would be telling us. There's no contracted length, there's no difference between the two. Now, that's not actually right. What's happening is when you plug this into your calculator, well, depending on what calculator you're using, mine at least does, it rounds. It rounds to a certain period, and you're not really able to see how much it's contracted. So the way we get by this is a pretty common trick. You could do the binomial expansion. And 1 minus beta to the 1/2, where beta is equal to v squared over c squared. I think that's what they usually call it, beta. If you want to expand this, I think I've done this before in my math video, that's just going to be 1 minus beta over 2. It's the same thing, just an approximation, and a good approximation. So with that, we can plug this into this part, and we get delta L is equal to L naught 1 minus 1 minus beta over 2, or delta L equals L naught 1 minus 1 plus beta over 2. Delta L equals L naught beta over 2. And beta is equal to v squared over c squared. So we substitute that in. You might not think this actually has any sort of impact on the answer you'd get in your calculator, but it actually does. You'll actually get a number now. It's granted a really small number, but that's what we expected. And if you plug this in, I got 2.14 times 10 to the negative 8th meter. So obviously, you know, who's going to notice that small of a change in terms of length contraction? But it does exist. It is there. It's just, with your calculator, it's not going to pick up on it because it's such a small change. It's going to just round it. That's all it's going to do. So that is the difference in length. Now for question B, it's basically the same idea, except we know it takes 50 hours, and they want to know how much less than 50 hours do they age. So now that we're dealing with time, this isn't length contraction anymore, this is time dilation. Okay? So first off, I'm going to just convert 50 hours, and we know this needs to be in units of seconds because C has units of seconds in it. And if you convert this, I get this many seconds. Okay? And we know T is equal to T naught gamma. This is our time dilation equation, which gamma is 1 over 1 minus v squared over c squared square root. So then we can say that this T is equal to T naught over 1 minus v squared over c squared. Okay, so that's just from our equation. Now to find the delta T, it's the exact same idea. T naught minus T. Okay? So, what can we do? Well, we can plug in what we know for T. So proper time minus the time dilation. And again, it's the same idea why we did L naught here and L there. This time will always be greater than this time. Or if you're not moving, they'll be the same number. In which case, delta T is 0, which is what we expect. So if you're confused on why it's that, that's why the order is what it is, or one way to think of it. And just using our definition of the time dilation, we can plug that in for t. And obviously we could factor out a t naught. Nothing wrong with that. And you'll run into the same problem as before. The same problem being you try putting it in your calculator, and the calculator is not really going to know what to do with that, so it doesn't really give you any change in time. Even though there is a change in time, it's just very small. So I'm going to rewrite this a little bit. It's the same idea though. We'll do 1 minus 1 times 1 minus beta to the negative 1/2. Let me do that a little nicer. And just like before, beta is v squared over c squared. And basically all I did was I moved this up to the front. Okay. Well, again, we can do our binomial expansion. So you'll have delta t equals t naught times 1 minus 1 minus 1/2 beta. So that's just me doing the expansion for that. It's kind of the same idea. I think there's just a different, in fact it is the exact same idea. There's just a negative instead from our Taylor series. And that's just because of the you're moving it up, so you have a negative in the exponent. But other than that, it's the same idea. Okay, so if we distribute that, delta t equals t naught, or I should say, well, yeah, distribute 1 minus 1 plus 1/2 beta. And you're going to get something very similar. Delta t is equal to t naught beta, which is v squared over c squared, which is this. And now if you plug this in, you're going to get a small number, which again we expected, which I got to be 7.717 times 10 to the negative 10 seconds. Okay, so obviously not much time dilation was experienced, but certainly some. And the big thing with these is obviously you need to know your equations, your length, contraction, and time dilation. But I think the big thing, and the reason why I did this one, is because you have to do a binomial expansion. And I'm pretty sure I've talked about that on my channel before, so if you're not familiar with that, certainly check that out. I do that here. Also subscribe if you haven't already. And yeah, that's everything.